Hi guys, how's it going? I hope you had a restful weekend. Monday today, which means time for some new videos, right? Uh, I've been getting some emails and about your progress with a common project problem. Everything looks like it's going well. If you need anything, let me know. We don't have it like a lot of time until the end of the semester. So I hope now you're kind of finalizing it. And but still, if you have any questions, I'm right here. Okay, so this week two more chapters that have to do with sports neuroscience and psychophysiology. I can see you watching my videos, are getting some good feedback, and I'm glad. I'm glad you're enjoying them, and hopefully they are increasing your interest towards this field and definitely helping you with your final project. So the very first video for today, as you can see, it's sport-related EEG activity, and we're going to talk about what we know so far from whatever the scientists have investigated. Okay, having my notes in front of me, so I don't want to forget anything. Always look at the comment section because I put an outline of what I am covering. It's not going to be a long video, but it includes a lot of information. Again, I'm just trying to combine it and give you the aggregated form. So let's start. There is some research, not a lot, that has to do with EEG and sports, and there are a few reviews out there. Okay, literature reviews. And the information presented today has to do with what I just mentioned. The research that's out there and the reviews that are out there of that research. We're going to try to answer some questions today and see some patterns that have to do with sports. Okay? Now, question number one. How does EEG activity change across the pre-performance period? First of all, what is pre-performance period? Is those seconds right before um, you do the activity. And as you know already, or if you don't, I'm letting you know right now. A lot of EEG research in sport has to do with those so-called closed sports, and especially with shooting, because it's easier, more controlled environment, and also we had issues with the level of how mobile are the EEG, whatever EEG tools we're using to record that activity. Now, let's go and answer that question. A lot of that research has to do with theta and alpha activity. And as I said again, shooting is very, very popular. The consensus is that alpha activity, especially in the left hemisphere, right, increases before we perform. What does that mean? The theory, the hypothesis behind it is, and we're going to talk about a lot of hypotheses today, so we don't necessarily have the answers. We see the correlations, but we don't know all of the time the causal relationship. We don't know the causality. Okay. Uh, so the left hemisphere has to do with analytical thought and attention. So if it is increased, that would mean less. And the hypothesis is that because there's automaticity, by repeating what you're doing, that's how we get that increased alpha on the left side. Second question number two, how is EEG activity different during good and poor performance, right? 2 points of agreement. Beat activity is lower in good, and that could mean that we may be less engaged. As I put in my notes, it looks like there's less cognitive effort, and especially in experts, we see more accuracy. And again, maybe it's because of automaticity. That's why we're less engaged. And those slow potential shifts, and I explain exactly what a slow potential shift are less negative, which is of course positive in this situation. Let's compare experts and novices. 2 points of agreement: theta activity and alpha activity are higher, right? So the hypothesis is that to get there, they can help us have a better ability to monitor cognitive load. That's a hypothesis. And also the EEG coherence, which is a lot of times we get signal when we're measuring EEG, like we had one signal. But of course, as the technology progressed, we have two signals or three signals. So when it's more than one, we can compare the two signals. They're measuring the same thing. There is a lower coherence, which means lower consistency between the signals, maybe again indicating some hemispheric specialization. As we said, for example, with the alpha, the left is showing a lot of changes. The right, a lot of times, is stable. Competitive athletes and non-athletes. What difference do we know? Theta and alpha is higher in competitive athletes. And when we talk about event-related potentials, and we talked about event-related potentials, ERPs, in our past videos, they're time-bound. Okay, and I use the example of the research we did here, that we changed intensity as somebody was on the bike, and we had, different epochs, different event-related potentials between the changes of intensity doing the same task, though, right? So are shorter, but the amplitudes may be higher. So we see that kind of reaction, that response, to be shorter, right? But the intensity to be higher. Is that the hypothesis? Is that some kind of result because of neural synchronization? That happens. Again, the answers, the whys, are not clearly explained. Between disabled and non-disabled athletes, there is some research, but not enough to give you any conclusions. Does practice and learning change the EEG activity? Okay, I'm guessing that the answer is yes, that you're expecting. We don't have enough data, but the answer is yes, especially about alpha. What about environmental manipulations? And I give some examples in the outline. So the conclusion here is that if we play with the stress level, right, having somebody do it by himself or yourself, and then put people around them, okay, changing the stress level. Imagine a game that's not important versus the game that you could, if you perform, you could win the championship, right? Or change the attentional focus of the athlete. That has an effect that increases the activation. And by increasing activation, as you can see, is less alpha, less theta, more beta. So beta will be higher and alpha and theta will be lower. That means more activation in our case. The main conclusion of everything that I explained right now, and again, there's so much information, a lot of research behind it in order to come with this kind of aggregated info, is that optimal performance that you see from the athletes is directly related with more economy. So the athlete, because they're trained to do it, they use less neural activity to perform whatever task compared to somebody else. The main theme that we see across all this research is that there is efficiency. So with the same resources, they can do more, or in order to do the same task, they use less resources than anybody else. I hope that makes sense. I'm going to create another video after I upload this today that has to do with neuroimaging techniques. I hope you enjoy them. Let me know if you have any questions. And as I always say at the end of these videos, lift intentionally or habitually. See you soon, guys.